So for the calculations, what I did is I set up my spreadsheet in Excel for the Southwest, and I've got just my tabs set up. Each of these tabs would hold a different set of calculations. So I'm working in a tab, and I just renamed it here and said Benchmark Southwest. Now, I entered my data here from the data we collected out in the field. So I've got my horizontal angle, my zenith angle, which is, like I said, the vertical angle, my slope distance, and I've got a description, and I've got my rod height of 4.75, actually it's 4.78, and I've got my instrument height of 4.66. Now, the way that I have it set up, I've got cells referenced. So I said to make a cell into an equation, you have to hit equal sign and then start your formula. You can actually have just one cell reference another, and that's usually what I do, so I can continue in one place and just keep referring instead of retyping the numbers. So I'll actually refer to cell locations. Cell locations are columns are going down and rows are going across. Columns start with the alphabet and rows start with the number. Now in trigonometric leveling, so what I need you to look at is what all these letters mean, because I use a Z for the zenith angle because that's how most textbooks read instead of V for vertical angle. We do use a V for vertical distance, and this is light blue line here. The H is the horizontal distance and the purple line here. We're going to be calculating V and H to compare with what we actually got out in the field. We also have our slope distance. So our slope distance is the values that we're going to use. So we're going to be using these given pieces of information. Now in Excel, I have to change my degrees, minutes, and seconds, here into decimal degrees. So if you take a look at this formula here, what it's doing is, I'm going to write it down over here just so you can see how it works. It's going to be equals and the degree here plus, I'm going to convert, so I've got open parentheses, the minutes times 1 divided by 60, close parentheses. That converts it to minutes into degrees. Plus, now I'm going to add my seconds times 1 over 3,600. That allows me to convert it into seconds. I forgot my parenthesis here. If you have a parenthesis, if I go through these, as it touches a parenthesis, it'll highlight the other parenthesis used. All right? So that's how I convert my degrees, minutes, and seconds into decimal degrees. And I can extend and have as many or as few decimal places shown. But the Excel program uses all of my decimal places. All right? Now, these numbers here are referenced to the previous data that we set up. By doing this, I've saved time, and I can copy this into the next block and type in the information here, and it'll automatically set up the program. By having blocks referenced or cells referenced, then the formulas can be easily calculated. Now I've got my northern and easting as the elevation set up here. And we will be using these variables in our equations. So I'm going to go ahead and move this down, and I'll show you how to do our first step is to actually calculate the elevation at B. Now, I'm going to say AB because the formulas are set up with AB, but we're looking at, we sat up at the southeast. I'll move this back. We sat up at southeast and looked to the southwest. So this is the location here is where my total station's at, and the Rodman's down here at the bottom. So this is the southeast benchmark, and this is the southwest benchmark. Okay. Now, in the formulas, to get the vertical distance here, we're going to take the slope distance times cosine of Z, the zenith angle or our vertical angle. So I'm going to say equals, and I'm going to find the slope distance that I've referenced here, multiply, and the multiply is by hitting Shift 8, it's that star, parenthesis, or cosine, parentheses, and I just typed in COS. Now here's where I take the degree, minutes, and seconds, but Excel doesn't use degrees, minutes, and seconds. It uses radians. So I have to multiply that by pi over 180. Now, I created an open parentheses. I type in pi, open parentheses, close parentheses. That automatically says 3.14 in all of its decimal places, divided by 180. Close parenthesis and hit enter. Oops, I've got a formula, or an error in my formula. I must have missed a closed parentheses. So take a look at the formula up here. Notice there's a black parenthesis and a black parenthesis. That's the entire formula that's taking the cosine of. See the two purple ones? That's open and close. Whenever you open a parenthesis, you have to close the parenthesis. And it's always important to understand your calculations by orders of operation. Everything inside the parentheses are done first. So I'm multiplying or doing whatever mathematical function inside the parenthesis first. Now I get a vertical distance of negative 7.026. If I look at this, let me bring this to the front. When I look at this, if I look at my southwest, my vertical distance is negative 7.03, which is really close to what I got based on calculation if I round. Now, it's negative because it is going down. And it's also, when I look at this, I know that I'm correct because anything, the vertical angle, when it's greater than 90 degrees, means I'm looking downhill. Now, I'm going to do the change in elevation, the distance from the line of sight to the actual ground where the rod's at. I'm going to say equal sign HI, the instrument height, plus my vertical distance, which is a minus sign, shift plus, so I go plus, minus that, minus the rod height. Now I have a plus here because this automatically takes care of the change in sign and equals. So it's a negative 7.146. I know it needs to be negative because I know that I'm higher at southeast than where I was on southwest. Now I'm going to figure out the elevation at the southwest benchmark. We're going to call it B for right now. We're going to say equals, and we're going to take the change in elevation at southeast, and we're going to add it to the change in elevation. And the change in elevation is negative, so it's going to actually subtract it. Now what it means here when you see all those pound signs means I've got too many decimal places. So I can actually just pull this over and change the decimal place. Okay? Or I can, oh, I know what it is. I need to change that number into general. Sorry, for whatever reason it doesn't like it as number. I have to tell how many decimal places. If that ever happens and you know it truly is a number, you can come up here and change to number. So it's 25.42. The actual elevation out at the benchmark southwest is 25.35, so we're really close. Now these are the equations that we're using over here, and this is in the literature review PDF that I asked you all to read. Now, cotangent of z is actually equal to 1 over the tangent of z. So I'm going to say the tangent of z, so I'm going to equal TAN, and I'm just typing this in, open parentheses, my z is decimal degrees, but remember we have to change it into degrees, minutes, and seconds. And I'm going to go ahead and put this inside a parenthesis. And I'm just using my mouse to move around in the equation. Okay? And now I'm going to take it and I'm going to go equal 1 divided by this value here is equal. Now, my horizontal is, I have to use this formula over here. So my horizontal is equal to the vertical divided by the 1 over tan z, which is this number here. Okay, so that horizontal distance here is 187.023. If I look at the data I have, my horizontal distance is 178, oops. So 187.023 187.023, and my slope distance was 100 and, ooh, I have a righto here, pause. There was a righto here, so it should have been 187.025. I was apparently dyslexic and wrote 7.8. So we were really close to the horizontal, the horizontal distance that we measured out in the field. All right. So we're going to go ahead and continue on. We will be using this calculated value for comparison as we move through. So we're not that far off. So we got 187.023 versus 187.025. Okay, so I'm going to pause here, and in the next part of the video, I'll show you how to do the calculations for the northing and easting.